Hello everyone, welcome back to Piece of Physics. In this particular video, we are going to see our new topic which is non-uniformly accelerated motion. Okay. In this particular topic, we are going to first find instantaneous velocity. So we have the formula of instantaneous velocity which is taken to be v equals to dx by dt. I can write it as dx equals to v dt. Okay. I can integrate the equation like this. Okay, so this can be written as from x naught to x. Time is from 0 to t1 to t2. Okay, so this particular equation can give you the displacement like x minus x naught equal to integration v dt t1 to t2. Now our second equation is instantaneous acceleration, which is a equals to dv by dt. Also, it is the doubling time derivative of displacement. Okay, so here you can also write it as dv equals to a dt. So you can integrate this equation like this: dv equals to integration a dt. Okay, so also we can write this equation as a equals to dv by dt to dx by dx. This can be written as dv by dx into dx by dt. So acceleration will be written as dx upon dt to dv by dx. Okay, so this can be written as v into dv by dx. Okay. Also, you can write it as v into dv into dx. Okay, so this is v dv adx. Okay, so here we are going to remember few formulas. One is this one, this one, this one, this one. So these five formulas are enough for the solving the non-uniformly accelerated motion questions. Okay, and basically you have to apply these particular problems, and also you have to remember this equation of acceleration as well. Okay, so total six formulas you have to remember for solving the problems of non-uniformly accelerated motion. We are given one equation. Instantaneous velocity of a particle moving in a straight line is given as v equals to 4 plus 4 square root of t meter per second. For the first 5 seconds of motion, then after velocity of its becomes a constant. Find the acceleration of the particle at time t equals to 3 meter per 3 second, and its displacement till this instant. Okay, so we are given velocity v equals to 4 plus 4 root t. Okay, now we have to find acceleration, which is going to be dv by dt 0 plus 4 d by dt t power half. So this is 4 into 1 by 2 and okay. So t half can be written as okay. So differentiation of t half is basically t minus half, and 1 by 2 we have taken ahead. Okay. So this will be 2 divided by square root of t. This is acceleration. Okay. So basically the formula of acceleration is 2 divided by square root of t. Okay. So acceleration at 3 seconds will be 2 divided by square root of 3 per second square. Okay, now we are given v equals to 4 plus 4 root t. Okay, so this is dx by dt 4 plus 4 root t. Okay, so dx will be equal to 4 dt plus 4 root t dt. Okay, so now we have to find the equation of displacement, so we'll integrate this equation like this. This is x and this will be 40 plus 4. This is t power 3 by 2 divided by 3 by 2. Okay, so we have to also put the limits like this. So here time is 0 to 3 seconds. So 0 to 3, here also 0 to. So this is x will be 4 3 minus 0 plus 3 by 2. 2 will go upward. This will be 8 by 3. This is 3 or 3 by 2 minus 0. So x will be 4 3s are 12 plus 8 by 3, and 3 power 3 by 2 will be okay. So 3 power 3 by 2 can be written as 3 root 3. Okay. Basically 3 will be cancelled with the 3. So x will be 12 8 root 3. Okay, so 12 plus 8 into 1.73. Okay, x is 12 plus 8 into 1.73. Okay, so 8 into 1.73 can be taken as this will be 13.76. Okay, so 12 plus 13.76. Okay, so x to 25.26. Okay, so displacement till this instant will be 25.76 meter, right? So displacement after 3 seconds will be 25.76 meter. Okay, our next problem is instantaneous velocity of an object varies with time as v equals to alpha minus beta square. Find its position and acceleration as a function of time. Also find the object's maximum positive displacement from the origin. So we are given v equals to alpha minus beta t square, and we have to find its acceleration as a function of time. The acceleration is basically dv by dt will be minus 2 beta t, and we have to find also position equations. This is dx by dt alpha minus beta t square. Okay, so dx will be equal to alpha dt beta t square dt. So this will be x will be okay. We are going to integrate this equation. This will be alpha t minus beta t cube by 3. Okay, so the position equation will be this one, and acceleration will be this. Okay. Also find the object's maximum positive displacement from the origin. Okay, so maximum positive displacement we have to find. For that, object should be raised after the motion. Okay, so let us take velocity to be 0. So here time will be square root of alpha by beta. Okay, so we are going to put this particular value here. Okay, so this is x will be equal to alpha root alpha by beta minus beta by 3 root alpha by beta power 3. Okay, so this is alpha 1 by 2 divided by square root of beta. Okay, minus, okay, this is beta alpha 3 by 2. In the denominator we are going to get 3 beta power 3 by 2. X will be basically alpha power 3 by 2 root beta minus this is alpha power 3 by 2 divided by 3 square root of beta. Okay, so this is going to basically 2 alpha 3 by 2 divided by 3 square root of beta. Okay, so the maximum positive displacement from the origin will be this much. Okay, so that's how we can find maximum positive displacement from the origin. Okay, so that's all for this particular problem. Now let us solve another problem. Okay, so in this particular problem, velocity is varying with x, as you can see v equals to alpha root x. So velocity v is alpha root x. Taking t equals to 0, x equals to 0, and t equals to 0. Okay, so we have to find velocity, acceleration, and of the particle as a function of time. Let us add one another parameter, which is displacement. So here we can take velocity as dx by dt alpha root x. So dx will be alpha root x. So this will be dx divided by root x equals to alpha dt. Okay, so I can write it as x power minus half dx equals to alpha dt. Okay, so now we'll going to integrate this equation. So this will be x power minus half 1 divided by minus half plus 1. This is alpha t. Okay, so we can write it as x power half divided by 1 by 2. This is going to be alpha t. This is x power half equals to alpha t by 2. So x will be alpha square t square by 4. Okay, So here one integration constant will be there. Okay, so, but from this initial condition, this turns out to be 0. Okay, so x is basically alpha square t square by 4. Now we can find velocity as a function of time. This will be dx by dt. Okay, so here the velocity will be again alpha square by 4, and this will be 2t. So velocity as a function of time will be alpha square by 2t, and by differentiating this again, velocity, this is alpha square t by 2. Acceleration will be alpha square by 2. Okay, so here the acceleration of the object is constant, which is time independent, so it doesn't change with the time. Okay, that's all for this particular problem. Stay connected to the channel for further videos. Thank you so much.